Can a large code have a better time complexity than a small code? Lot of you have been asking this question since last week, and I know that we just discussed time complexity and space complexity in last video, so it is very obvious to have this doubt. So welcome to class 4 of DSA series. In this video we are going to deep dive on what is time complexity actually, and we will see that we'll see how to compare time complexity of two codes, and in the end we will be addressing this particular question, that can a large code have better time complexity than a small code. So let's discuss the topic of discussion. So first of all, what we are going to do in this video, we are going to discuss a topic known as operations in a code. What is called operations in a code. So we know that time complexity, we discussed in last video, that time complexity is not only the runtime of your code, because runtime can vary depending upon system to system, code to code, right? What it is mainly dependent upon is number of operations, and number of operations in a code determine the runtime. Okay, so yes, time complexity is dependent upon runtime, but what is the actual definition of time complexity, that is still not clear, and that we will discuss in this particular video. Okay, so we will discuss about the formal definition of time complexity. So what is formal definition of time complexity? And after that, in the end, we will evaluate certain cases, we'll compare certain cases, and we will see how their codes runtime varies here and there. Okay, so these three are the topic of discussion of this videos. So tune in, watch the complete video, and let's start with it. So let us start with the discussion on what is the meaning of operations in a code. Okay, so operations in a code technically means any computational task that your code is doing, as simple as that. So any computational task which your code is doing. Now what is the meaning of a computational task? It means that, for example, it could be a variable assignment, like you created some variable. It could be any operation like addition, subtraction, multiplication, division, anything. It could be a print statement that you are doing. Okay, or maybe you're running a loop, or you're calling a function, you're defining a function. So any type of thing that you do in your code, that is called operation. So let us discuss this thing little bit in more detail. For example, let us say this is a code. We are defining a variable a equal to 10, b is equal to 5, c is equal to a plus b, and then we are doing print c. Okay, so we see that there are 4 operations in this particular code. First of all, we are defining a variable a. Second, we are defining a variable b. Then we are defining another variable c, which is a plus b, and then we are doing a print statement. Okay, so this means this particular code has 4 operations. Now let us say there is a list. For example, a is equal to 10, 20, 30, 40, 50. So there is a list with 5 elements. Now let's say I'm running a loop for a in, so let's name it list. For a in list, print a. So what is happening in this particular code is that the first step is this. The first operation is this, where you define a list with a particular value. And after that, in this for loop, we are iterating 5 times. Okay, first we are going to 10, then we are going to, so what are we doing? First of all, we are going to each element, and then we are printing them. So we are printing one by one. So this is the first operation. This is the second operation. This is the third operation. 4, 5, 6. So there are total of 6 operations in this particular code. Similarly, like you can keep on exploring. Any particular code has lot of operations depending upon things. So now what matters to us in case of time complexity is that so let's say, so let me clear this first of all. So what matters to us in case of time complexity is that how does the number of operation vary with the size of the data set that I'm working upon. So what is the time complexity? The formal definition of time complexity is it is the rate of change of your number of operations. Okay, rate of change of your number of operations with respect to the size of data set. Okay, with respect to data set size. So what do you mean by data set size? I'll just explain it here. So let us say we have let us say we have this particular printing statement where we're printing a list. So let me just delete it. Okay, now what we'll be doing is that we will calculate the number of operations which are present for various cases in this particular case. So if we see this particular code, there are 6 operations when the size of data set is 5. Okay, so if you see there, so let's write down operations and size of data set. So let's evaluate here. First of all, if you see, when we have the size as 5, number of operations were 6. So operations were 6 and the size was 5. Now what happens if I increase the size? For example, let's say I do 60, 70, 80, 90, 100. I have included 10 variables, 10 values inside this list. So number of operations will become, first operation will be the list assignment, and then there will be 10 operations like this. Okay, so 10 plus 11. So my operation, when I move the size to 10, it will become 11. Okay, now similarly, when I make the size 15, my operations will become 16. When I make the size 20, my operations will become 21. So what is time complexity in this particular scenario? If you have to calculate, so time complexity is equal to, so operation 2 minus operation 1 divided by size 2 minus size 1. So this is the meaning of time complexity. So for example, 11 minus 6 divided by 10 minus 5. Okay, so this is approximately equal to 1. So it means that it is your time complexity is dependent upon your number of value like elements which are present inside your data set. Okay, so what does it mean that as your size grows? So what we are seeing here is that as my size of data set is increasing, my operation size is also increasing. Now what is the rate of this particular increase? That is what determines time complexity. And for few cases, your increase of size will not have any impact on number of operations, and few cases it will be a linear relationship. For few cases it will be a quadratic relationship. Like we will discuss those particular relationships which are called big O in the next video, but let's just try to understand that your operations vary depending upon the size of your data set, and this is what determines time complexity. So time complexity is not the runtime of your code. Time complexity means the rate of change of number of operations in your code with respect to the size of your data set. Okay, so I hope this explanation is clear. Now we will move to further discussion. So now that we just discussed the formal definition of time complexity, let's understand a little bit more in detail. So for example, as we discussed, what are called operations? Operations can be anything. It can be accessing data, performing calculations, comparison, like doing where A is equal to B, looping, function calls. There can be different types of operations in your code, but not all operations affect your time complexity in the same way, because we discussed that time complexity is the rate of change of your operations. Okay, so rate of delta operations with respect to data size, correct? With respect to data size. Now all operations do not change with respect to data size, and we will see that with an example of a code. For example, let's say we have a list here. What we have to do, so let's say there is a list equal to, again let's say for example 20, 25, 30, 35 and 40. Let's say there is a list with 5 elements. Now what we want to see is that we want to calculate the sum of all elements in a list inside a variable. So how do we do that? We will simply create a variable total equal to 0 first of all, and then what we are going to do, so let's write down a simple print, okay, so f processing your sum now, okay, something like this we write. And now after this, what is going to happen is for a in list, okay, and we will do total is equal to total plus a, and eventually we are going to print f sum of elements in your list is, for example, total. Okay, so this is the part that we are doing, and we'll close this f statement. So if you see that what is happening in this particular code, there are multiple operations. We will discuss them one by one. So first of all, we are defining this list, then we are creating a total, then we are printing a statement, then we are technically accessing each element one by one, and then we are summing up. So let's see. Now there are two types of operations in your code. One is a constant operation. These operations take a fixed amount of time and do not depend upon the size of your input. And then there are dependent operations which depend upon the size of your data set. So in this particular code, let's say when I run this code multiple times, does my list assignment happen multiple times? Like this only execute once, right? So number of operations for this will remain 1, because this is a single operation only. This is not this particular, even if my size of data set, let's say, becomes 50, 60, 70, does not matter. This will still remain one operation for me, correct? So this will remain one operation only, and it is independent of data size, correct? Now let me just copy this. We will keep assigning this to various elements. Now total equal to 0. Now tell me that does the assignment of a variable total equal to 0 depend upon the size of data set? No, because we are doing just it for the one time. Does not matter my size of data set is 15, 20, 2000, 50,000, does not matter, right? So this is also of single of this operation also does not depend upon your size of data set. Now the third part is print. Now we are just printing right now, processing your sum right now. So this will not have any impact. This will also be only independent of your data sets. Okay. Now come to this particular part. What is happening for a in list? This particular part will increase as, for example, right now there are 1, 2, 3, 4, 5, 6, 7, 8 operations. Once I increase the data set, it will iterate. For example, let's say I increase from 8 to 10, it will iterate from 1 to 10, right? So 10 operations, 15 operations, 20 operations. So this particular part will depend upon the size of data set. Okay. Now, so I will write, so this is dependent on the size of my data set. Okay. So this is the thing. And this particular part is also dependent on the size of data set, because every time I loop, I am doing a total equal to total plus a. So this is also dependent upon the size of the data set. And the last statement which we are doing, it is independent of data set size, because this only run once. We are just printing in the end that sum is independent of data set size. So what we see in this small piece of code, that there can be multiple operations, but some operations affect the data, some operations are affected by data size, and some operations are not affected by data size. And this is what determines time complexity, that how does your operations vary based on the size of your data set. And so that's what determines time complexity. So while calculating time complexity, these particular things will not have any significant impact. That's why the runtime of your code does not matter. For example, you can write 100 statements like this, but it will not affect the time complexity of your code. But if you write just two pieces of code like this, it will affect the time complexity. And this is what something you need to ingrain in your mind. Time complexity is the rate of change of observations that your code is doing. And what are the observations? Observations can be static like this, and they can be dynamic like this. And we have to cater that particular thing only through our codes. So for example, we just discussed this particular thing, right? So there is a constant operation like assigning result equal to 0. This is done once and does not change with the input size. Printing a message, but there is a loop, and loop will depend upon my data set size. So I hope this particular part is also clear, that how your operations is dependent upon the like operations are of different types, and time complexity depends upon the type of operations that you have involved in your code. So finally, let's look at the number of operations involved in such type of code when you have different size of your data set, right? For example, 40, 60, like, so how are the number of size vary? How number of size vary? For example, in this we have the first is O1. O1 means constant time complexity. So first two are O1. The third was ON, because we are going inside the loop n times. This particular step is O1 actually, but because we are repeating it n times, right? So it becomes O of n. It means it depends upon the size of a data set. And the last one is constant time. It means that we are just printing one. Now let's tabulate this thing. So I have created a table to show you this particular part, that how the number of operations increases as the input size increase. Okay, so if you see the first column is the input size. What is the input size? Input size is the size of this particular list. Okay, so when we have one element, so we have one constant operation. Sorry, so we have this constant operation, this constant operation. Okay, let's say for the time being I remove this one. Let's say I remove the print statement. Okay, so what are we having? So input size is 1. Now constant operation is 2. So this is first constant operation, this is second constant operation, and then we have loop operations 1. So this will happen only 1, because the data size will be 1 only. Okay, so total of operations in my particular data set, in my particular code, will be 3. Now let us say I increase the input size to 2. So what will happen? This will be 20, then 40. So this will still execute once only, right? So the total of constant operations will remain 2, but number of loop operations will become 2, because this will happen 2 times now. Similarly, if you see, as we increase the size of the data size, so the constant operation will always be executed this many times, but the loop operations will keep on increasing 1, 2, 3, 5, blah 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 blah, right, up to 100 depending upon the size, and the total operations will be the sum of these two. So 2 plus 1, 2 plus 2, right? So if you see, total operations is varying linearly with your input size. Now this relationship can be linear, can be quadratic, as I mentioned earlier. That totally depends upon how your like how many loops you are having, how many things you are doing. So that particular discussion we will have on Thursday's video. But when we discuss various like various big O's, O(n), O1, O(n square), O log n, we will discuss those particular topics in that video. But right now I just want you guys, because I'm repeating this again and again, because so that it goes deep in your mind, that time complexity is the number of operation, and number of operations depend upon either constant number of operations is actually constant operations plus dynamic operations. Now constant operation will not have much effect on the time complexity, because it will, number of operations does not depend upon this. Number of operation depend upon your loops, right, or function calling. So that is why when we see number of operation, we actually determine with this particular thing. Rate of change of operations is called time complexity. So please ingrain this thing in your mind. In the next video, we will talk about the visualization of these time complexities. But just as this video finishes, please fix this in your mind, that time complexity is the rate of change of operations of in your code. And what are operations? Operations can be constant operations, or they can be loop operations, or they can be dynamic, right? And what affects total operations for time complexity is the dynamic operation, not the static operations. So I hope this explanation is clear now. Let me know if you have any particular doubt for this particular video, and in the next video, as I mentioned, we will start visualizing the time complexity.